Okay, so very good morning to all. This is our third lecture for this our non-conventional machining subject. Okay. In the last lecture, we have started the first point, that is why do we need advanced machining process or why do we need non-conventional machining process? Okay, the basic question we have started and we have discussed also. Now the remaining part of that lecture we'll see. Okay, before that I will take just a recap on the points whatever do we have discussed. Okay, so we have started with the engineering materials. Okay, what are the engineering materials nowadays in the industries, various industries, which materials are used? Okay, and from that, what are the limitations on for that to machine that materials, and the way how seen that how to solve that problem. And the answer was the our non-conventional machining processes. Then we have discussed that what are the present demand trends in the various industries and how they are facing the problems. Okay, and how to solve the problems, and its answer again the advanced machining process. Then we have gone for the some limitations of the we have seen some limitations of conventional machining processes. Okay, and how to resolve that problem. Okay, about that how to overcome with the that problem of the limitations of the conventional machining. Okay, and the answer was the advanced machining process. Okay, now coming to the today's point. Okay, I'm continuing that why do we need advanced machining process. Okay, the remaining part we are going to see now. Okay, now as we have seen that about the workpiece properties. Okay, now apart from the workpiece material properties, there is another aspect is that there are the aspect of the product is that product requirement. Okay, there are the product requirement. Okay, which are very complex in shapes. Okay, that means whatever your shape of the your product is there, sometimes it may be in a very complex. Okay, so you may be required to machine means what you would consider the process. Machine here is the process, so you may require a machine a component in inaccessible areas. Okay, which may not be feasible for your conventional machine process, or I can say as a which is not feasible for the your conventional cutting tools. Okay, so for example, say a single point cutting tool if you use, or multi-point cutting tool if you use for machining that complex or inaccessible areas. So using that also, if it is not feasible, then definitely you have to go for, or you have you require advanced machining processes or your non-conventional machining processes. Okay, to get the accurate size and shape of that such a complex component. Okay, so there maybe you require tool very small tolerance. Okay, say 10 micrometer, or even smaller than that of the 10 micrometer. If you want to achieve that, then you have to go for the advanced machining process. Okay, so that is depend upon the requirement of component. Okay, so that is a one aspect of product requirement, that is a complex shape. And again the limitations that machining in inaccessible areas. Okay, for that purpose you have to go for the advanced machining process. Then I have talked about the if you want to achieve the small tolerance, that is say 10 micron, then you have to go for the advanced machining. Now I will talk about the product requirement. Another point, that is a better surface integrity. To achieve, or sometime you need better surface integrity. Now here it is very important to understand that what is mean by surface integrity. What is mean by surface integrity? Okay, so surface after machining. Okay, so after machining, whatever the surface you will get, okay, whatever surface you will get after the machining, that should not have any effect, okay, on that surface, such as micro cracks should not be there on your surface of your component or the product, or there should not be poor surface finish, or there should not be any heat affected zone. Okay, if such defects or a poor surface integrity is there, if you will get from the conventional, then we have to avoid that conventional machining process. You have to take the alternative, that is the advanced machining process, to achieve the better surface integrity. That is the for the requirement of your product, okay, to get or to achieve better surface integrity. There should not be any surface defects on your surface. Okay, so such defect or poor surface integrity should not be there. Otherwise, what will happen? Your product may get rejected during the inspection. Okay, so if you want better surface integrity, then you have to go for the advanced machining process or non-conventional machining process. Getting it? Okay, and now we'll go for the another aspect of the product or requirement of product, that is a miniaturization of product. Okay, so this is another aspect which forces us to use the advanced machining process. Okay, you can see this point also I was discussing in the last lecture. So you can see in the older days or even today also, we use landline phones, okay, which are much bigger in size as compared to our mobile phone. Okay, landline phones is a bigger in size, okay, as compared to your phone, mobile phone. So what are the available phones, these mobiles have the much more capabilities, okay, than the your landline phones. Okay, you can internet with the help of your mobiles, you can send the emails, okay, and do the financial transactions also. Okay, so that are the capabilities of the mobile phones. Okay, so everything is compacted in a very small size of your product, that is your mobile phone. Okay, so your landline phone, it is miniaturized into the your phone, that is called the miniaturization product. And nowadays that is the need of today's era, miniaturization of any product. Again, one more example I will give is that in older days, okay, in older computer, if you say in 70s era or 80s era, so your old computer of having the size of the one this is my cabin, so more than that cabin size, so computer was there. Okay, so our room size could not have and what are the phone was sorry, computer was there, no, so that could not have the memory more than what we have in today's our laptop. Okay, in our laptop we have the 1 TB and 2 TB hard disk. Okay, and in older days near about 216 MB, like that the it's a storage capacity was there. But whatever the miniaturization happened from the your computer to the laptop having the more capability, so this miniaturization requires very small size of component, correct? If your product is small, compact inside, that means in that of that product component will be very small. To get that miniaturization, okay, what are the required in small size of your component would again with different capabilities. I'm asking about, I'm talking about the capabilities also. So for machining that small components or for machining these components, you definitely require the processes other than your traditional or conventional machining process. So what are the another or other process than the your conventional means the our advanced or non-conventional machining process. So this is the another point about the product requirement, okay, which forces us to use the non-conventional machining process or advanced machining process. Okay, now I will talk about the okay material removal rate, that is high material removal. Now in the industries, what happened, one of the industries always talking about the high production rate. High production rate, they need manufacturing processes which can give high productivity with no compromise in the on your quality, especially while processing difficult to machine materials. Okay, some materials are there which are difficult to machine, that means which are difficult to cut or the turn perform the different processes on that material. So about while processing that materials, industries are taking care of the production rate or the it's a productivity. So they always demand, industry always demand that the cost of your product production should be as low as possible. Okay, cost of production should be as low as possible, so that they can earn more profit or they can have the higher profit. Okay, so high production rate means what? High material removal rate. Okay, within less time, industry want more product. Okay, that means the high productivity. If they want high productivity means what? They should go for high material removal rate. Okay, and using traditional machining process, in many times or in many cases, you will not get the high production rate. Okay, so you have to take the another alternatives for the machining process, that is the advanced machining process, or that is your non-conventional machining. Okay, now I will talk the another point, that is precision and ultra machining process. Okay, why I'm talking about the precision and high ultra machining, because you have to go for the low cost production. So precision and ultra precision machining or nano level machining are the requirement of today's this sophisticated high tech industries. Okay, which one cannot fulfill with the help of our conventional or the traditional machining process. So we have to go for the precision and ultra precision machining processes. Okay, in this today's sophisticated high tech industries, Okay, so which is not possible or which is not fulfilled with the help of conventional machining process. So we have to go for the advanced machining process. Okay, to get the material high material removal rate. Okay, now for example, nano level surface finish if you want, or if you want tolerance less than 10 micron. Okay, that cannot be achieved with your conventional machining process. Okay, which removes the material in the form of chips, where the size of your chips, okay, out of the material removed from the your product or the component is there no, so it is called the chips. Okay, so that chips itself is a few hundreds of the micrometer or more than that. Okay, I'm talking about the conventional. So you need to need processes where you are removing the material in the form of atoms or the in the forms of micron. Okay, you need a processes where you can remove the material in the form of atoms or in the form of molecules. Okay, now whether it is possible to get the your chips in the form of atoms or the molecule, it is not possible using conventional machining process. So you have you have to if you want to achieve that material removal or removal of the material in the form of atoms and the molecules, okay, that can be achieved only through the your advanced machining processes, as it is possible with this non-conventional machining process. So this is the another point or another reason which leads us to or forces us to use of this. Why do we need an advanced machining process? Okay, getting it. So these are the reasons or these are the needs about the advanced machining or non-conventional machining process. Okay, so this is the answer. Okay, what are the points I have discussed in the last lecture and until now? Okay, so that is the reasons why do we need to learn or why do we need to go for the advanced machining process. Okay, so this is the importance of our subject. Okay, so now I will say that this is a solution. Okay, this is a final the solution. What are the reasons or problems are there? So it's a solution is the lies in this advanced machining process or non-conventional machining process. Okay. Now let us go for the let us discuss some interesting examples of the component which cannot be machined by our conventional machining method. Once again, I will repeat. Let us discuss some interesting examples of the component which cannot be machined by using the conventional machining methods. Okay, so you can see this slide. Okay, on this slide, top left hand corner, top left hand corner, this one. This one. This is a top left and corner of our slide. So there are two carro holes are that you can see these two. So there are two carro holes are there with a wall in between the two holes. Okay, two holes are there and in between that two holes wall is there. Okay, now to drill a hole perpendicular to this wall. Okay, to drill a hole perpendicular to this wall is very difficult because why it is difficult? Because the hole's diameter is there, no, it is near about 1 millimeter. Okay, it is the diameter of this hole is near about 1 mm and hole length is say around 100. What are the length is there? So it is around 100. Okay, so it is difficult to drill that holes. So the question arises is that which conventional machining method can do this? Which conventional machining method can do this? To the best of my knowledge or my understanding, I would say there is no conventional method can drill a hole like this in such a component. Okay, it is not possible using any conventional machining to drill a hole having diameter 1 mm and the length is 100. So we need to go for the advanced machining process. So as yet we have not started the classification of the conventional non-conventional machining process. So just I will give the one example. Only electrochemical machining process ECG, sorry ECM, electrochemical machining can serve your purpose. That means electrochemical machining can do the drill of having 1 mm diameter and 100 mm length. So as we will discuss that process later. So electrochemical machining ECM is able to drill such holes, okay, normal to your wall surface, okay, perpendicular to your wall surface. Okay, this is one example. Now another example. Okay, in the second figure, this one. Okay, in the second figure, there are cooling holes are there. These are the cooling holes. Okay, in the turbine, this is a turbine blade, and on the surface of the turbine blade there are the cooling holes. Okay, in the turbine blades, and the diameter of these cooling holes are very small. Diameter of these cooling holes are very small. Okay, now the size of these cooling holes is normally 2 mm, and the depth is quite large than this higher aspect ratio. If you consider the higher aspect ratio, then the length is more than that, 1 or 2 mm. Okay, and what are the material is there? No, so material of these turbine blades is superalloys. Okay, that point we have discussed in the last lecture. The material of the this turbine blade is a superalloys. Okay, so for this purpose there is a process, advanced machining process called shaped tube electromachining process. STEM, STEM, shaped tube electromachining. Okay, that process can achieve the purpose of this. What are the you want to drill the holes on this turbine blade, cooling turbine. Okay, so for this purpose, there are the competitive or process. This, okay, that also this shaped tube electromachining process. It is not in our syllabus, but we'll see. Okay, so that is also advanced machining process. Okay. Now, what are the present day design of the our turbine blades are there no cooling holes that does not recommend straight side cooling holes. Okay, in the turbine blades, what are the holes are there? That is not a straight. They are in at what in tapered holes or the inclined holes are there. Okay, that means complex in nature. So that is not possible using any conventional machining process. You have to go for the non-conventional or advanced machining process. Getting it? Okay. Now we'll go for the another. Okay. So these are the processes. The holes. Now we'll go for this another one example. Okay, in this slide, bottom left hand side, this figure shows this actually this male and female part. This is a male part and this is a female part. Okay, so this male part has been taken out from the original solid blank of the of having the definite. This is a blank. This is a blank. Okay, from this blank, this male part is taken out. Okay, and after taking out the male part, the what are the left out part is there in the form. It is called the female matching part. This is a female matching part of the one product. So the difference in the dimension of the features of this female part and the male part is only that few 100 micron. Okay, if you see the dimension, so it's differ by the one just 100 microns or less than that. It's depending upon the diameter of the wire which is used for machining. Okay, diameter of the wire which is used for the machining, because whatever the process is used to get this product, that process is the one of the advanced machining process, and the name is that your wire EDM, wire electrode discharge machining process. Okay, so wire EDM process is used to get or to produce this precision your product. Okay, okay, so you can fit that male part, this part into this female part, and you can use it as a single product. Okay, by fitting your male part into the female part, you will get a single product, and that you can use. Okay, you cannot make such a kind of such a type of component by any of our conventional machining process. So definitely you have to go for the advanced machining process or advanced non-conventional machining process. Okay, now here is another example of a 3D component. This is a 3D component. Okay, this fourth one. What are the I have highlighted this. Okay. Okay, this is a 3D component which is I have shown on the left bottom, bottom right hand side, this of this slide. So such kind of 3D component you can make easily by using any conventional machine. Any non-conventional machine, because such a 3D complex shape, it is not possible to produce using the conventional machining process. You have to go for advanced machining process. Okay, so this kind of 3D component can be easily made by using your wire ADM process, that is wire electrodischarge machining process, or wire electrochemical machining process, and some other advanced machining process also. Okay, that we will discuss them later on. Okay, all the processes we are going to discuss later on. Okay, another example I will show. So here are the some more examples. Okay, in the slides. Yes, here are the some more examples where you really need to go for the advanced machining process. Okay, so the top left hand side, this one. Okay, corner. So this is a part of a mind having many holes. Okay, this is a part of helicopter turbine. Okay, having many holes. Okay, which is drilled by the EDM process. Sorry, electron beam machining. Okay, because the what are the size of these holes is there? No holes size. It is very small. Okay, shapes are varying from location to location. That hole size. Okay, as you can see here also. So the thickness of this particular component is very small. Okay, maybe less than millimeter, but very hard material is there. So the question arises is that how to make such a holes on this component? How to make such a holes? How to make these holes? Okay, you cannot make it by any of the conventional methods. Okay, so otherwise your component it may be wrapped up or it get damaged if you use the conventional machining process. So the only process which can be used for this particular case is the electron beam machining process. Okay, electron beam machining process. Using the electron beam machining process, you can produce such a component. You can see the hole size. These are the holes. Okay, you can see. Okay, now another example I will see. Now I'm going to talk about this one. This is another example. Okay, see this figure in the middle. Okay, this one. So hole diameter, we'll talk about this also. Hole diameter is in this particular case is just 90 micron. Okay, and the density is 4,000 volts per centimeter square. So the question arises that how to produce such holes, small holes. So you have to go for the advanced machining process. Okay, and that is also you can actually using the electron beam machining process. Electron beam machining process. Okay. Now we'll see this. Okay, so there are other examples also. This figure I have shown that purpose of a octangle. Okay, or we can call concaves or concave shaped components. Okay, you can see concave or convex component. Okay, to finish this internal surface to the nano level surface roughness value, it is not possible in conventional machining process. So question arises that which process or processes should be used to get this nano level surface roughness value. Okay, one cannot use the grinding or honing or a lapping process to get. So the process that can serve your purpose is your abrasive flow finishing process or magnetorheological abrasive flow finishing machine. Okay, mechanical processes are there. Okay, so using that you can actually this process. Okay, actually that process whatever I am talking abrasive flow finishing process, but Now, let us discuss some important characteristics of our this advanced machining process or non-conventional machining process and tools, machine tools also. Okay, here I have shown some important characteristics of non-conventional machining process. So the first is the performance of that majority this advanced machining processes now, so that its performance is independent of the your what are the strength barrier is there. Okay, that means the workpiece strength barrier is there. No, that means the hardness of the component. Okay, so it does not affect on your performance. It is independent of strength of barrier. Then the performance, what are the performance of the processes are there? No, it totally depends on the your thermal, electrical, magnetic, or chemical properties of your workpiece workpiece material. Performance, it's what are the processes are there? No, so it's a performance is totally thermal, electrical, chemical, magnetic. Okay, so I was talking about the this characteristics of the processes. So first is all the processes are the independent of the on the barriers. Okay, there is no barrier of the hardness, but it depends on the properties of the your workpiece material. Okay, like thermal, electrical, chemical, magnetic properties. Okay, and these all non-conventional machining processes are processes use different kinds of energy in the direct form. Okay, depending on this use of different kinds of energies, no, yeah, form of energy, your processes are classified. That we are going to see. Okay, whether your material is electrical, conductive, or non-conductive. Depending on that, also we have the different processes. Okay, and in some cases it depends on the chemical properties of your component also. So namely electrochemical process, chemical that is equivalent to the your workpiece material. Okay, that will control the your material remote rate. Okay, so it depends on the properties. Okay, now I am discussing about the use of different kinds of the energy. So what are the advanced machine processes are there? No, they use different kind of energy in either direct form. Okay, for example, if you take the example of the laser beam machining, okay, or electron beam machining process, or ion beam machining, so their electrical spark energy is used. Okay, so in general, what are the metal remote rate is there? No, okay, in general, what are the your metal remote rate for the advanced machining processes are there? No, so it's having the low metal remote rate. But what are the quality you will get? No, so its quality is very good. Okay, so here one more characteristic is that you will get the low metal remote rate. Okay, now that doesn't mean that all the processes having the low metal remote rate. Some process having the low metal remote rate, some process having the high metal remote rate also. But if you use any advanced machining process, then you will get the better quality of your product. Okay, then the most important point is that about this one. Okay, about the investment. So whatever the investment is there, for example, if you want a good lathe machine, conventional lathe machine, so that can be brought for about 10 lakh rupees or so. Okay, within 10 lakh rupees you can purchase, you can buy conventional lathe machine. Okay, but if you want to go, if you go to buy a simple electrochemical machining, then it will cost not less than 20,000. Sorry, 20 lakh.
Okay, if you want to buy electron beam or electron chemical machine, then it will not cost less than 20 lakh. Okay. On the other hand, if you want to buy electron beam machine, okay, then it will have the cost around 100 lakh. Okay. Okay. But again, if you consider another focus ion beam machining, okay, that may cost as near about the 600 lakhs also. Okay, you are even more than that also. That means the initial investment is now that initial investment cost of any advanced machining process is higher than comparatively to your conventional machining process. Okay, so advanced machining processes having more high initial investment cost, okay, as compared to the conventional machining process. But you will get the better surface finish, better quality of product. Okay, so these are the some aspects. Okay, so these are the some important points. Now, what are the I have discussed up to this lecture. So if you want to need more information, then you can use this advanced machining process by VK Jain book. Okay, advanced machining process book. Okay, you will get in our study material PDF copy. No, you will get the sorry in study material sheet. You will get this book also. You can refer. So this was just a basic topic of our related to our subject. Okay, now let us start with our first chapter. Okay. Okay. Now let us start with our first chapter, and the name of the first chapter is Overview of Non-Conventional Machining Processes. Okay. Now in this chapter we are going to see the introduction to the non-conventional machining process. Then we are going to discuss the need of non-conventional machining processes that we have already discussed. But once again, I will just quickly I will tell. Then classification is the main important point of our first chapter. Okay, and then we'll go for the overview of non-conventional. Now let us discuss the introduction. Okay, this part also I have discussed the last lecture, but once again we'll discuss. Now, as we know that our what are the manufacturing processes are there, no? Okay, that can be broadly divided into the two parts. Okay, one is the primary manufacturing processes, and second is the secondary manufacturing process. Okay, now in the primary manufacturing processes, these provide basic shape and size to the material as per the design requirement. Okay, what are the processes available? That is a traditional machine process, like casting, forming, powder metallurgy. So these are the primarily manufacturing processes. Okay, which gives or which provide us basic size and shape as per the to the your component as per the requirement. Okay, and this, another processes are the secondary manufacturing processes. Secondary manufacturing processes. So these processes provide us a final shape and size with tighter control on the your dimension. Okay, and as well as your surface characteristics also. Okay, what are the surface characteristics you want? That is surface high surface finish or low surface roughness value, right? Accurate size and shape. Okay, so that can be achieved using the your secondary manufacturing process. And whatever material removal processes are there, no, that are mainly belongs to the this secondary manufacturing process. Okay, all the material removal processes are mainly secondary manufacturing process. Please write on this point, secondary manufacturing. Okay, so here I will request you all of you, please write the chapter name. Okay, unit number 1, overview of non-conventional machining process, and in that write down the just manufacturing processes. In that first primary manufacturing process, secondary manufacturing process, and under that you can write down the material removal processes. Okay, please write down. I will give the 1 minute time to write down to write this. Just write name only. No need to write in detail. Just a highlighting point. I will give 1 minute. All of you, please write down. Okay, now let us discuss the next. That is, now what are the material removal processes are there? That are the secondary manufacturing processes. Now, what are the material removal processes are there? No, that divided into the 2 groups. One group is the your conventional machining process. Okay, and second group is the non-conventional or non-traditional machining processes. Now, what are the conventional machining processes? These are the processes mostly remove your material in the form of chips by applying forces on your workpiece with a edge-shaped cutting tool. Okay, which is or that is harder than your workpiece material, which is harder than your work material. That means hardness of your tool material should be higher than your workpiece material. Now, which are that conventional machining processes? We know that our process means your turning, boring, drilling, slotting, shaping, milling, grinding. All are the processes conventional machining process. Okay. Now another group of our material remote process is the non-traditional or non-conventional machining process, or you can call it as a advanced machining process. Now it's the definition I will tell. It is defined as a group of processes. It is defined as a group of processes that remove excess material by various techniques. Okay, these are the processes remove the excess material by various techniques involving mechanical, thermal, then electrical or chemical energy or combination of these energies. Okay, but do not use a sharp cutting tool, which is needs to be used for your traditional machining process. Okay, here in non-conventional machining, in advanced machining process, we do not require any sharp cutting tool, and we do not have any barrier about the that hardness. Okay, material properties. Okay, so whatever the processes we are going to discuss in our non-conventional machining processes, all are the non-traditional machining process group. Okay, now here some example I have given. That is the advanced, that is average jet machining, electrode discharge machining. Okay, electric discharge machining, electrochemical machining, laser beam machining, electron beam machining, plasma arc machining. All are these 14 processes belongs to the non-traditional machining processes. Okay, that we are going to discuss in this chapter. Okay, now in the next lecture we will start with the classification. That is first point of the our first chapter. Okay, I have discussed the introduction. In the next lecture we'll start the next point. Now here first I request all of you, please write on your roll number in the chat box, and after writing your roll number in the chat box you can do this meeting, no problem. Okay. And before that, please write on this conventional and non-conventional machining definition. Please write on your this conventional and non-conventional definition. Then leave this meeting. Please write down the definition of non-conventional machining process. Okay, you should know the basic fundament of our what is the mean by conventional and non-conventional machining process. Please write down. Okay, if you have written this conventional, non-conventional, and if you have written your roll number in the chat box, you can do this meeting. Okay, thank you very much. See you in the next lecture.